So, generally speaking, the sliding filament theory explains the mechanism that allows muscles to contract. When speaking about muscle contraction, it kind of helps if you understand the different acting parts of the sarcomere, um, myosin, actin, the Z line, tropomyosin, and troponin. The Z discs, or some people call them the Z lines, are like little zigzag boundaries on either side of the sarcomere that link together the actin filaments. So, for the process to begin, you need an AP generated to release acetylcholine. This stimulates the muscle. So then calcium is released, and that binds to the troponin, shifting the actin filaments, exposing the binding sites, and this is kind of where the Z discs come more into play. So the myosin cross bridges attach and detach, pulling the actin filaments towards the center, and as those actin filaments are pulled towards the center, the Z lines are coming together towards the center as well, pushing those actin filaments so that they can slide over the myosin and create the cross bridges. So this action requires ATP, and then the muscle contracts. So after that, the calcium is removed, shifting the actin filaments back out. The Z discs go back out and to their original position and block the binding sites, and then the muscle relaxes.
Hi, so today I'm going to be talking about the role of troponin in the sliding filament theory and how it relates and regulates to muscle contraction. So first you need to know what tropomyosin is. I'm sure the person before me explained it great, but for this case, tropomyosin is essentially a protein that binds to the actin filament, and during muscle relaxation, blocks myosin from getting where it needs to go in order to create a muscle contraction and continue the sliding filament theory. Well, this is where troponin comes into place. Troponin essentially is considered the bolts for tropomyosin to that actin filament, and this essentially allows troponin to dictate where tropomyosin is placed on the actin filament. In order for the process to continue and for a muscle to contract, troponin mixed with a high concentration of calcium are bonded together, and this essentially conforms troponin and pushes tropomyosin out of the way. So tropomyosin isn't blocking the myosin from moving down the filament. With that being said, the sliding filament theory can then continue. Without troponin, tropomyosin blocks myosin from attaching to any necessary space and sliding up the actin. And then troponin moves the tropomyosin out of the way so that we can contract our muscle and also control our muscle movements.
I'm going to be talking about actin, which is a protein that is part of the sliding filament theory. Actin's main role in the sliding filament theory is going to be a binding site. It allows for a hormone called troponin to bind to the actin. This then causes the tropomyosin to shift so that the myosin heads can then connect to the actin. This then causes the actin filaments to slide, and then the cross bridges are formed, which then makes way for the muscle to continue to be able to contract.
Myosin is one of the two primary myofilaments that bind with actin to cause a muscle action. Myosin is a thicker filament with distinct components. The molecule has two globular heads, called myosin heads, S1 units or cross bridges, that are attached to protein strands. The components containing the cross bridges are sometimes referred to as the heavy chains. The protein strands intertwine to form long shafts called tails or light chains. Hundreds of myosin molecules are packed tail to tail in a sheath with the globular heads pointed in one direction along half of the filament and in the opposite direction along the other half. In the middle, where no globular heads are present, is the M line. Myosin is secured along its longitudinal axis partly by thin filaments of the protein titin. 6 actin filaments surround each myosin filament. In muscle contraction, the myosin globular heads extend as cross bridges and bind to specific sites on the actin filament, forming the structural and functional link between the two filaments.
Like troponin, tropomyosin is a protein on the actin filament. Once troponin binds with calcium, it causes my position to change and exposes an active site for myosin to combine to actin. You can think of me like a defensive line. Before the play starts, before the contraction starts, I'm not moving, but I'm still in a blocking position. Once the play starts, once the contraction starts, I move out of the way to create an opening for the running back for myosin to bind to actin. Next, myosin will explain their role.